when we see an expression of this form, x to a power a, then here a we call either a power or an index, or sometimes it's called an exponent. You'll see all three of these words used in different contexts. When a here is an integer, so a number like 4, 22, let's say n is an integer, what we mean by this expression is x multiplied by itself n times. So there are n versions of x all multiplied together. When we see the expression x raised to the power minus n, then that's a reciprocal. That's 1 over x to the power n, which we could write as 1 over x times x times x times x, etc. All the way up to there. There are a couple of other different notations for indices. These powers, x to the power 0, x to the power 0 is always equal to 1. And x to the power 1, well, x to the power 1 is x multiplied, well, not multiplied by itself at all, just itself. So that would be x. Okay, so these 4 different rules for the basic laws of powers should be definitions that you should remember. There are some basic laws of powers that you may have met before, but you need to understand. And I'll write those down now. So if we are to have x to the a multiplied by x to the b, then this can be simplified to x to the a plus b. So if this was x squared and x cubed, x to the power 2 and x to the power 3, this will be x to the power 2 plus 3, or 5. Alternatively, if we have x to the power a over x to the power b, then we can simplify this by x to the power a minus b. We can actually think about this as that reciprocal before, because this really is equivalent to x to the a times x to the minus b. The 1 over x to the b here is the same as x to the minus b. And combining those two, a and minus b, using the top rule, gives us x to the a minus b. The third important rule here is that if I have x to the a and I want to raise the whole thing to a power b, so this is x to the a multiplied by itself b times, then this is actually equivalent to x to the a times b. Not plus or minus, this is a times b. Another expression, if I've got x multiplied by y and I want to raise that to a power a, then that's equivalent of saying x to the power a multiplied by y to the power a. So again, simplifying these kind of expressions will give us useful simplified mathematics. So as an example, we take an example. The example I want to choose is 8 to the power 2 over 3. Okay, so I'm going to write over here the laws of indices that I'm going to use. The first thing I'm going to think about is that x to the a times b is in fact x to the a raised to a power b. Now, how's that going to be useful? It doesn't look like I've got something like of that form. But in fact, this is 8 to the power 2 times a third. Okay, so 8 to the power 2 times a third, that looks similar to this here. I can rewrite that as 8 squared all to the power a third. Alternatively, I could rewrite that, in fact, as slightly differently, 8 to the power a third raised to the power 2 squared. Both are equivalent expressions. Now 8 squared I can work out. 8 squared is 64. 8 times 8. And I need to remember to raise that to a power a third. Alternatively, if I use this method, then 8 to the power a third, I have to think about what that third power is. And we should remember that anything raised to a fraction like that, 1 over n, is actually an nth root. So you can think about this as x to the nth root. What does the nth root mean? It means what number, when multiplied by itself n times, gives me my number x. So here, what number, when multiplied 3 times by itself, gives me 8? Well, 2 does. 2 times 2 times 2, 3 times, gives me 8. So here, this would be 2 squared. Well, this way is looking pretty simple. I can now do 2 squared. That's 4. Hopefully this is going to give me the same answer. What's the third root? 1 over 3 power of 64. So again, I have to think to myself, what number, when multiplied by itself 3 times, gives me 64? Well, in fact, 4 is the correct answer. 4 times 4 times 4 is indeed 64. So whichever way you do it, you get the answer 4. So here, and there are many different ways of doing these kind of problems, but you always will get out the same answer. Our second example, a slightly more complicated example, I'm going to look at a to the power 1 over 6 times b to the power 2 over 3, all raised to the power 3. So I'm going to use 2 of the laws of indices now. I'm going to use the fact that x to the power a all to the power b is x to the a times b. And I'm also going to use the fact that x multiplied by y, all raised to a power a, is actually x to the power a, y to the power a. Okay, well, let's use that second rule first, because I've got a quantity here, which I'm going to think of as one quantity, let's call it x, and another quantity here, which is the y. So I can expand out that bracket, and I get a to the power 1 over 6 to the power 3, b to the power 2 over 3 to the power 3, and those two things have to be the same. And now each of these individual parts here, I'm going to use that first property. So all I do is, when I've got a to the power 6 to the power 3, is then multiply the a and the b, multiply those two indices. A to the power 1 over 6 times 3, and similarly with b to the power 2 over 3 times 3. Okay, and now we just have to do this relatively simple fractions. 3 over 6 is a half, and then the b to the power 2 over 3 times 3, 2 over 3 times 3 is 2. And that's the simplest form of this problem.